We're live. First participant in straight at 12 o'clock.
Always good to see. Always good to see.
So guys, if you're dialing in now, we're going to give people a couple of minutes to get set as well. So just bear with us while we give people a moment or so to join the call. But thanks for joining our tech recruitment training today, our deep dive into artificial intelligence.
I'm very excited for this one. I think it was our most requested session so far. So, and possibly the biggest buzzword in any industry right now. So I'm very, very excited for today.
Yes, should be a good one indeed.
A great one to make your audio and video debut, Daisy.
Oh my goodness, I know. I do prefer to be behind the scenes, but you can wheel me out occasionally.
For those wondering where Phil and Darren are, we decided we'd give them this week off based on all of the work the last 2 weeks. They do have some day jobs that they need to get on with as well, but they will be back next week. Do not worry. So you will get your fix of Phil and Darren next week.
Yes. I mean, I wish we could imagine them like with sombreros on, like sunning themselves in a hot country, but yeah, no, sadly, like the rest of us, they're in England, but yeah.
Yeah, they are in lockdown like the rest of us.
But with the magic of the Zoom backgrounds, they can imagine to be wherever they want to be. So
yes, this is true.
I
was literally just going to say we had a call this morning and some people did some really good Zoom backgrounds. So
yeah, Dale, you can mention Tiger King again.
Is there an update on Tiger King? Oh my God, I've not been keeping up to date with that.
No, someone on our company Zoom this morning put Carol Baskin as their background on
oh,
Zoom.
I did. Yes, I did see that. I'm gonna have to try and source that, but I'm pleased that my Zoom skills haven't hijacked these sessions yet, so I haven't decided to showboat yet with the custom backgrounds.
That's a good point. Actually, we should have looked into that.
Maybe next week. So guys, how are we doing with numbers?
Yeah,
I think we're slowing down on the joiners now, so I think we're ready to kick off. So guys, it is Wednesday, it's 12 o'clock. That must mean it's the start of our weekly resumption of tech recruitment training. So I think many of you will have seen our 2-week course we ran for the previous 2 weeks, at the end of April, beginning of May. So if you're a fan of that, welcome back. And our most requested topic from the session, the polling we did of our audience, was to do a session on AI or artificial intelligence. So we are back in our weekly time slot now, and I'm delighted to say that we're joined by Mark, who I think many of our viewers will be familiar with, and first time in visual context, our erstwhile moderator, Daisy, is going to be manning the Q&A and making sure we stay in check in other manners as usual. I'm going to try and get my cursor key to work, and hopefully it does. And brilliantly, here we are. So just a reminder, a bit of housekeeping. We are running a Slack group to complement the video sessions and the webinars. And tomorrow, Phil, if you're getting Phil withdrawal symptoms, you can join us on Slack, where Phil will be running a 30-minute Ask Me Anything. So if you've got any questions that you had from the previous sessions or from the sessions today, Phil will be on hand to answer those at 3 p.m. UK time tomorrow, so Thursday tomorrow. Just a reminder, if you're using the Q&A or the comments section today, please get your comments and questions in there, but we'd ask you to use the all panelists and attendees. That means everyone gets to see the conversation and keep track with the comments and questions. And we have been overwhelmed, I think it's fair to say, by the positive feedback we received from this series. So thank you for that. Just a reminder, the whole backlog of videos is available on a YouTube series, which is pretty easy to find. And if you want to tell your friends about that, you can tell them through Twitter with our handle hackerjob_co, or I think we've got a big and active LinkedIn community, so lots of people mentioning us there. Polite request, if you can use the hashtags either TRT or Tech Recruitment Training, that would be fantastic. So a few people just sidle into the group. And last minute, so guys, don't worry, we just managed the housekeeping. We're about to start now. So just a reminder again, the sessions are now going to move to weekly. Today we've done it on a Wednesday, but going forward, we're going to run these 12 to 1 on Tuesdays, and probably with those follow-up Ask Me Anything sessions on Wednesdays, but we'll keep you updated on that. Our next topic is going to be on data engineering, which I think was our second most requested topic, which I think has quite a bit of overlap with the AI and artificial intelligence subjects that we're going to cover today with Mark. And then I think we need to give you an update on quiz results and our Hacker Job Wine Club. So I think Daisy, you might be the best person to update us on those.
Yeah, sure. So with the wine club, please look out for an invite in your inbox this week if you've attended enough sessions. So please look out for that. And with the quiz results, Mark is going to be doing a video later today that we will be sharing on social, and we will be emailing the winners separately as well.
Fantastic. Wow, so you're keeping us in suspense there. Great. So moving on, I think Mark, can you talk us through the today's agenda about artificial intelligence, please?
Yeah, absolutely. Thanks, Dale, and hello everyone. So today we're gonna start with just a quite a high level intro to artificial intelligence and a bit of the history of AI in the modern sense. When I was doing some research for this session, it has been around for hundreds of years as a concept, but we're going to be looking at the more modern history. And that's going to take up a bulk of the session, and the remainder of the session will be focused on different AI techniques. So I think what we'll see throughout the session today is a lot of terms within the AI world are used interchangeably. So probably most common artificial intelligence and machine learning, but they are two different things, and we'll be talking through that in the technique section. And then finally, we're going to be talking through how it applies to the world of work from an employment perspective, because whilst yes, there are AI engineers, there are also other roles that will utilize artificial intelligence as well. So that's the plan for today. I'm really, really excited to get people's Q&As on what we discuss.
Great, super. Thanks, Mark. So I think starting off, what is artificial intelligence? I think the images that are conjured to mind are either sort of very dystopian world of machines taking over the world. But I think the theme that we're going to cover today is there's lots of positive implications for artificial intelligence, and we're already experiencing them on a day-to-day basis. And that a lot of the roles that we've covered in the earlier sessions are all starting to have this overlap with artificial intelligence. So it isn't necessarily a role as such, I think you're going to explain, but something that is a thread throughout lots of the different roles and disciplines that we're covering through these sessions.
Yeah, absolutely, Dale. And I think, you know, if we look at artificial intelligence now, it pretty much touches every company. You know, whether that be your employer or us at HackerJob, most companies are now looking at how they benefit from it. But what is it at a high level? So artificial intelligence at a very high level is a branch of computer science. So if you have done a computer science degree, a CS degree, there will naturally would have been modules throughout around artificial intelligence because it's a branch of that. But effectively, what we are trying to do with artificial intelligence is build systems, build functions that can operate automatically by themselves in an intelligent manner. And that's the key. It's the combination of autonomy and intelligence in a system, not a human. And we'll go through it in a second. There's various different types of AI, but they're all trying to achieve that same goal of intelligence in an automated or autonomous fashion. And what powers artificial intelligence are various different types of algorithms and different techniques and how you apply those algorithms. So some of the techniques we'll be jumping in today is machine learning, which is probably the biggest advancement over the last 20 years or so. Deep learning, which is a subset of machine learning, but also looking at stuff like natural language processing and computer vision. All of those different techniques are using various different types of algorithms to achieve the goal of building systems that operate intelligently and autonomously. So if we flick onto the next one, Dale, there's a couple of different types of artificial intelligence, ranging from where we are today to kind of the dystopian type future. So what we have got exceptionally good at over the last 10 to 15 years is building what is known as narrow AI, or you might also see it be called weak AI. And what narrow AI does is machines that are very specific on one task. So a great example of this that I'm sure probably most people are aware of is AlphaGo, which was a system built by the guys over at DeepMind that beat the best Go player in the world. And that was seen as something that would take decades to achieve, and was achieved actually very quickly. And that's really where we're at with AI at the moment, is very narrow, specific use cases. You then have general AI, might also be called strong AI, and that is kind of what people think of the kind of holy grail, where we really want to get to. And that's creating systems that are as intelligent as a human. And depending on the literature in the market that you read, some people say this is decades away, some people say this is centuries away. And we'll talk through it in a second, but the big test here is what's known as the Turing test, which can a machine trick a human in thinking that they are a human? So we're not there yet. We're not particularly close to creating general AI, or artificial general intelligence, it might also be called. And then the third type is kind of the Skynet dystopian future, which is where we create machines that are more intelligent and more self-aware than human intelligence. And that's kind of the scary element. You know, that's why people like Stephen Hawking or Elon Musk or I think maybe Bill Gates have said that AI is the biggest threat to humanity, because of this potential that we end up creating a machine that actually surpasses human intelligence, and we are its servants. So that's the different types of AI that we can build. But really important to highlight at the moment, we've only really nailed narrow AI. We're not close to creating what would be called artificial general intelligence.
Fantastic. Okay, so with a little bit of intrepidation, let's try and find out some of the origins of AI. Just talk us through, maybe, as you say, although I think a lot of people think about AI in the sort of current technology context and maybe with this sort of future dystopian view. As you said in your introduction, Mark, something with a bit of history. So talk us through some of this.
Yeah, absolutely. And we'll keep the history lessons short. Everyone knows I like my history lessons, but we'll keep them short. So artificial intelligence is not a new topic. It's not something that has come up, in the internet era. It has been a branch of computer science since the 50s. So, and actually in literature way before that, but for the purpose of this session, we're going to focus on this today. So I'm sure all of you will know who Alan Turing is. And if you don't, go and check him out. He's a fascinating person. And I think there was a movie made about him called The Imitation Game, which is a brilliant movie. And he was a huge part of the UK winning World War II. He was working at, what's the park there? You know what it's called?
Bletchley Park.
Bletchley Park, that's right. And he created the Enigma code, which deciphered the German messages, etc., etc. And after the World War II ended, he went on to create the Turing test in 1950. And he started basically asking questions around, can a machine trick a human into thinking that they are a human? And that's kind of being perceived as the main test for artificial general intelligence. Can we create a machine that not only solves a very specific task, but has the creativity of a human, has the intuition of a human, etc.? So really pinnacle part of trying to build artificial general intelligence. You then have what was known as the Dartmouth Summer Project, where 5 or 6 different researchers got together to kind of build on top of this Turing test. And that was where the term artificial intelligence was created. So that was back in 1955, so 65 years ago now. And in this era, it was very exciting. People were thinking, wow, we're going to create machines that are as smart as humans. And there was a lot of hype around artificial intelligence. And there were kind of 2 broad schools of thought about how we were going to achieve it. So we had a top-down approach, which was basically going to program specific rules into a computer to mimic human behavior. And we had a bottom-up approach, which said, actually the best way is to kind of map out neural networks, basically replicate the human brain in a machine and let it learn for itself. For whatever reason, the top-down approach was considered the better solution at the time, the better approach. So that was the one that was kind of the leading approach and defined AI of this era. So one of the big success stories of this era was Eliza, which was a chatbot, which was effectively programmed rules on what to say when people said what. So this era, very exciting, lots of hype, etc., etc. But as we will see next, kind of failed to live up to the hype. So in the early 70s, if we go on to the next slide there, we'll move on to what's known as the first AI winter. And it was called the AI winter as a bit of a play on words on the nuclear winter. But basically you had this sort of 15 years of a lot of hype. Machines are going to create, humans are going to create machines that are more intelligent than humans, etc. And it failed. The reality was it's impossible to pre-program a machine with all of the different attributes of a human. The task is just too big. And there was a very, very famous mathematician at the time. I can't remember what his first name was, Mr. Lighthill. He was knighted. He was so famous. And he basically said that artificial intelligence was a load of hype. We would never even be able to beat an amateur player at chess using artificial intelligence. And that report kind of led to all of the funding in the UK being cut, and there was similar actions in the US as well. So all of the academic funding was suddenly cut for AI. And there was very, very little progress in this sort of 15-year window after kind of a lot of hype initially. And then if we move on to the next phase, Dale, we saw a little bit of a resurgence in the 80s, but not from an academic standpoint. So what we saw happen in the 80s was firms started to see the commercial value of AI in very narrow, specific examples. And these got dubbed expert systems. So this era of AI was really about creating expert systems. And what an expert system was a very specific task that could perform at a level far greater than a human. So the first commercial example of this was Digital Equipment Corporation, who I'm sure we've all heard of, created a new system for managing orders of their computers. And back in the 80s, it was estimated to save them $40 million a year. It's a huge, huge saving. And there were several other examples around the world about organizations using AI to build expert systems to solve very narrow problems. And this was kind of the end of the first AI winter. But still nowhere near the grand idea of artificial general intelligence that was set out in the 50s. If we then move on to the 90s, and some of this might start ringing some bells now, is we kind of evolved from expert systems to what was known as the era of intelligent agents. And this was basically an idea of you set them a goal, and then they will work autonomously to reach that goal. And the best example of this was, I think it was IBM, created Deep Blue, which was a machine that learned how to play chess, and it beat the chess grandmaster. So it was an amazing achievement. If you think about the Lighthill report in the 70s, it said, AI would never be able to beat an amateur level chess player. What they showed was they beat the grandmaster, the best of the best in the world at that point. And this was using a top-down approach, so a rule-based AI. And the criticism was that it was kind of just brute forcing. It wasn't real intelligence. Deep Blue couldn't do basic things that like a 2-year-old human could do, but they could play chess to an exceptional standard. And the other thing that was really interesting about the 90s is we saw a bit of a revival of the bottom-up approach. After that initially came about in the 50s, it was kind of just put into a very esoteric part of AI, not very much interest. But in the 90s, we start to see a bit of resurgence of this idea around building neural networks, which, as we'll come on to later, is kind of a key component of AI today. And then if we move into the sort of modern era, Dale, of AI, it's kind of an era defined by machine learning. And what's caused this explosion is kind of two parts, which is one, the amount of data that is available now. So you'll see that all of the modern AI systems, or vast majority of them, are trained on vast amounts of data that simply we couldn't have decades ago. But as we've discussed in some of the big data topics already, you're now getting terabytes and petabytes of data collected that enables you to train these systems. And there's also a big reduction in the cost of computational power that actually takes to run these systems. So what we've seen over the last 15, 20 years is using multiple AI techniques combined, which we'll come on to in a second, with a very bottom-up approach to solving problems. So we're not programming rules top down. We're using a combination of different techniques to let the AI create its own intelligence. And a couple of examples we've got here, Dale. I know you're a big fan of the IBM Watson winning Jeopardy, which was a US TV show. Obviously, we've got AlphaGo that beat the best player in the world in Go, which was seen to be decades away from happening. And probably something that you all have used before is Apple obviously launched Siri in 2011, I believe. So this is kind of the era we're in now, which is summed up by lots of data, cheaper computational power, and a combination of different AI techniques to achieve certain goals.
Cool, thanks, Mark. So loving the history lesson. Say a fellow history traveller here as well. For the boffins out there, it's James Lighthill. Google has told me is the mathematician that wrote the Lighthill report that dawned the AI winter. Bletchley Park now a museum dedicated to the World War II code breakers. So I think post lockdown, an informative day out in Buckinghamshire for anyone that's engaged. And I think for those that aren't aware, Go is like a even more complex version of chess, which is popular in China and other Asian countries, I think.
Yeah, absolutely.
And I think there's a very interesting documentary which we might find a link to and put in the Slack group later today or tomorrow.
Is that the Netflix one?
Yeah, I think so.
Yeah, brilliant.
As we've not mentioned Tiger King thus far, we think Netflix was overdue a mention in the series. So, great history lesson. I feel very informed and brought up to date now. So maybe now is the moment to talk through some of those AI techniques. How are people using AI in the modern setting?
Yeah, and I think this is probably more interesting for the majority of people. I appreciate maybe not everybody enjoys our history lessons, but I think it's important to understand where these concepts come from. So the different techniques, and we use the word techniques, it's not necessarily, there's not necessarily a specific word out there that people are utilizing today. Obviously, the main one being machine learning, which is got a subset called deep learning. You've then got computer vision is another broad technique that people use, natural language processing, also known as NLP, and artificially intelligent robots, which we'll come on to because robotics in itself isn't using AI. Again, some really common misconceptions. So before we jump into these topics, just something to be really clear about is that you cannot, in a correct sense, use machine learning and artificial intelligence as substitutes for each other. They are fundamentally different things. Artificial intelligence is the goal of trying to create machines that can operate intelligently and autonomously. Machine learning is a technique that achieves that. So just for future reference in terms of mixing those two up. But if we move on there, we've got machine learning up first, and this is absolutely probably the one that gets talked about the most at the moment. But machine learning it's a relatively simple concept to understand. It's not overly complex. So from a how it works perspective, it's a data-based learning technique. So not using databases, but uses a lot of data to learn. And effectively what you do with a machine learning algorithm is you give it loads of data. Could be anything. Images of cats is the most common example I see. Give it lots of data. It will then learn from that data by processing it and then make decisions over time. So it will understand, feed it data, understand the data, take a decision. And the more it does that, the better it becomes. And we're going to talk through different learning techniques and how it does that slightly later. But at a high level, that's all machine learning is doing. Understanding data, learning from it, making decisions. Very, very straightforward. As we mentioned, the why it's become the go-to method over the last 20 years is because of that combination of a lot of data and the cheapness of the computer to process that data. So if you go back 20 years when it costs thousands and thousands of pounds to be able to store terabytes of data, and now, you know, you can do that with tens of pounds. You can imagine why it's exploded so much, combined with the fact that we've now got smartphones that are collecting more data than ever before. I think, Dale, there's the common analogy that, you know, the technology in your iPhone is more sophisticated and more powerful than the technology that put people on the moon. So just shows to go where that's been. And really interesting concept for your really boffins out there, I guess, is to understand Moore's law, which is a core understanding of this, which basically says that over a certain period of time, the price of a processing chip basically halves. There's two broad cases for machine learning. There are a couple of others, but at a high level, it's used in two different ways. So it's used at a classification stage, which is basically using data to assign certain objects to a group. So I guess an example here, let's say you've got 10,000 customers. You could run a machine learning algorithm that classifies those 10,000 customers into different groups. So, I don't know, you could have retail customers, financial service customers, consultancies, etc., etc. Or it's used for predictions, making predictions. So it will say, you know, based on all of the data that I've been able to consume, I predict that this is most likely to happen. And I think the example we're going to give in a second there is using it as a prediction mechanism.
Yeah, and we see this quite often in sales teams trying to predict, you know, which client they need to call next. These sort of systems in big organizations become very, very commonplace.
Yeah, absolutely. If you look at Salesforce's, you know, the number one CRM, as Mark Benioff will tell you, they've got what they call Einstein, which is fundamentally using machine learning to trawl through all of your CRM data to then make recommendations on who to call next, which customers are likely to churn, who can you upsell, etc., etc.
Okay, so I think we've got a machine learning example here.
Yeah, so I assume most people use Spotify. I'm a big Spotify user. So a really cool example of how machine learning is used is these two playlists on Spotify. So everyone's got their own personalized versions of either your Discover Weekly or your Release Radar. These are powered by machine learning. So what Spotify does is it understands all of the songs you listen to most often, the genre of those songs, the BPM of those songs, the tones of those songs, the artists, etc., add all of that to a machine learning model, and then will predict what songs you're likely to listen to that you haven't heard of yet. And that's what you've got with the Discover Weekly playlist. And surprisingly good, actually. I do listen to my Discover Weekly quite often because it's a great way to discover new artists and new songs that you haven't heard before. And similar concept with Release Radar. And Spotify have been really well recognized as an organization that has used machine learning in an incredibly effective way. I still think they're probably the leaders out of all of the streaming platforms for music when it comes to their prediction models about what you're likely to listen to next, and they've got some really smart people running that. But a great example using machine learning that just simply wouldn't have been possible 20 or 30 years ago, and something that we all use daily.
Oh, great example.
I'm sorry,
Yeah.
I was going to say, speaking of machine learning, so we've had a question about machine learning and artificial intelligence and how they differ from RPA. So for those who don't know, RPA is robotic process automation. And obviously, so RPA is kind of designed to reduce human efforts. And it's a software that does mimic human actions, I believe, Mark. But if you could kind of tell us how that is slightly different to machine learning and AI.
Yeah, absolutely. So RPA's exploded. I think UiPath is probably the leader at the moment and is growing at just a ridiculous rate. I don't think we've ever seen a tech business grow as quickly as UiPath is currently growing. And Dave, you're absolutely spot on with what you said. So RPA is about mimicking human behavior to complete a certain task. And it's being used all over. It's not being used just in manufacturing. It's being used in finance. It's being used in pretty much every sector. You can achieve RPA without using machine learning and AI, and I think we'll come on to this a little bit later with robotics as well, is that you can achieve these without using machine learning or AI, just a different technique. So RPA, you could take the approach that you're just going to set a very strict list of rules that this application needs to do, and you just program that application to just do that. So there's no learning component to it. It's not going to get better over time. You just tell it, click these 8 buttons in this order over and over again, and that could be RPA. And I think you can For those who like a little LinkedIn trick out there are definitely Chrome extensions you can get that automate behavior on LinkedIn, and it's using Selenium, which is something we would have talked about using in the QA section, testing section. So you can achieve RPA without using AI, machine learning, though I suspect, I don't know this for sure, but I suspect the leading RPA companies like UiPath are probably using RPA bots that are programmed, but then using machine learning techniques to make them more intelligent over time. So I think you will be able to apply machine learning and AI to the world of RPA, but it's not necessarily a prerequisite for the world of RPA. Hopefully that explains.
Cool. Yeah, you can definitely go down some rabbit holes in this subject area, and the nuances will definitely be hotly debated. I'm sure for some time to come. If we move things along, then, so we've said that deep learning is a subset of machine learning. Mark, just unpick that one for us, please.
Yeah, and again, I think you can often see machine learning and deep learning be used as synonyms, but again, they are different things. So if you think AI top branch, you've then got machine learning, which is a branch of AI. You've now got deep learning, which is a branch of machine learning. So rather than taking the machine learning approach, which is to feed it data, let it understand that data and make decisions, what deep learning is doing is replicating the human brain. So I don't know if too many people have studied the human brain on this webinar. I certainly haven't. But from what I understand about the human brain, is it is built up of a lot of neurons that effectively end up combining together to be a neural network. And how we make decisions, how we learn, et cetera, is through that neural network. Now, if you remember the history lesson back in the 50s, this was way back then when people thought you could do this. So what people have tried to do with deep learning is mimic the human brain in terms of structure, but do it in a computer system. So rather than just having a single algorithm work on a machine learning technique, you're layering algorithms on top of each other to replicate a neural network. And it's called an artificial neural network because it's not a real neural network. And what this approach does is basically say, here's the outcome, go and figure out how to do it. So AlphaGo, you could not have brute forced AlphaGo because there are too many variations in the game of Go to be able to program for every single outcome. So what they needed to do was create a system where it could learn by itself. And the most effective way for it to do that was to create this artificial neural network. And what was amazing about AlphaGo, and why I'd really recommend the documentary, is it ended up being very creative. They were saying the moves that the AlphaGo was making was not just a logic probability-based decision. It was like creative flair in their approach, which we've never seen before in an artificial intelligent system. And there's a couple of different, there's loads of different neural networks that you can use. A couple of most common ones used, which we'll come on to slightly later. You've got what's called a convolutional neural network, which is effectively reading like a human would, or actually, sorry, how we in the West read, which is left to right, top to bottom. Quite often used in computer vision, which we'll come on to shortly. You've got recurrent neural networks, which spot patterns and predict what happens next, quite often used in natural language processing, which we'll come on to in a second as well. So what you'll see throughout is that one of the big things that is now happening is we're combining AI techniques together to solve problems. And deep learning is kind of at the forefront of that with its neural network structure. Appreciate that's quite complex. Please jump in and ask questions if any of that doesn't make sense. Really want this to be as valuable as possible for you guys. But think of deep learning as trying to replicate the human brain in a system that can start taking decisions and learn by itself.
Cool. Okay. So just give us an example then here, I think, of how deep learning works in practice.
Yeah, so I think loads of good examples. This was one that was a couple of years ago. It came out at Google's annual convention, and there's a product they've built on top of this now. But effectively, Google Translate, for those of you who use it, it's a simple translation system, but really struggled, to be honest. You could get the general gist of what people were saying, but as you'll see in this example, we've got some Hindi text. And before they applied a deep learning algorithm to it, it said that evenings are likely to rain, please take the umbrella with you. And I think that's a common thing you'll see in translations, is it will get the the verbs and the nouns mixed up because of sentence structure. What deep learning allows it to do is to actually learn over time and get a lot more accurate. So you can now see the new translation on Google Translate is, there is a possibility of rain in the evening, please take the umbrella with you, which now makes grammatical sense. The first one didn't. And that's been achieved purely using deep learning techniques to do that. They've now released there, I'm not sure if you've seen it, like something you can put into your ear and it will translate in real time, which is mind-boggling. I haven't played around with it. I don't know how good it is, but again, that's using neural nets as a broad technique to teach the algorithms.
Yeah, I think that's something along the lines of the hypocritical babblefish, isn't it?
I don't know what that is there.
I think it's a mythical creature that you put in your ear and it automatically translates all languages for you. I might be wrong, but let's see if anyone corrects me in the comments.
Love it. Maybe that was the inspiration for the engineers at Google that built it.
Let's see. Maybe a quick look on Google just to verify some of that information. Let's move swiftly on. Daisy, have we had any questions come up before we move on to learning techniques?
Not so far, no.
We simply have a highly engrossed audience eager for more. So Mark, without further ado, talk us through the different learning techniques.
Yeah, and guys, please jump in and ask questions if this isn't making sense. I'm assuming that the lack of question is we're doing such a great job, but if there is anything that's confusing or you feel like we've not got to the bottom of, please let us know. So using machine learning and deep learning, you've got different learning techniques. You know, just like how different humans learn in different ways. Some might be more visual, some might be more audio, etc. Our machines learn in different ways as well. And generally speaking, there are three broad strategies or three broad techniques when it comes to building these learning systems. So the first one you've got is supervised learning. And this is training our algorithms on a data set that already provides the answer. So this is a great cat example. So Google Photos is probably the leader in the world at the moment for using AI on photo recognition. Their first approach was literally to tag like millions and millions of photos manually with like, that's a cat, that's a cat, that's a cat, that's a cat. And then would feed that data into an algorithm that would then be able to, over time, be able to spot a cat because of how many cats it has seen before. It works incredibly well, but you can see it requires a lot of structured data to be able to do this. So there, I think we've seen now in a lot of the big tech firms, they literally employ hundreds and thousands of people doing very manual tasks about labeling data to train these algorithms. So that is what we mean when we talk about a supervised learning model. And you'll see different algorithms on candidate CVs and on job descriptions that you want people to have experience with. But some of the most common for supervised learning would be linear regression, random forest, which is probably one of the more common ones, and another one called support vector, which are just different styles of algorithms, tend to be used in different use cases, depending on what you're trying to teach the system. You then have unsupervised learning. So what unsupervised learning does is you feed the system data again. So you could, again, let's stick with photos. You could feed the system 100 photos of the same 5 people in a group photo, or same 5 people. And what you're asking the machine to do is pattern recognition. So you want to pick up all of the different patterns in the photos, and then maybe in this case, sort them out. So if there's 100 photos of 5 different people, an unsupervised learning algorithm would be able to then put them into 5 different piles of here's Clive, here's Susie, here's Bob, etc., etc. So we're giving it the data, but in an unstructured way. So you can imagine this is a slightly more advanced technique. This is often when neural nets will be used. And again, you've got a couple of different examples of algorithms there. You've got k-means algorithms, you've got a priori algorithms, etc. And they're just used in different use cases. And then naturally, whenever you've got 2, you normally have a hybrid approach, which is the reinforcement learning, also known as semi-supervised. And here you're using a goal-based system. So all of the computer programs you see, I think there's now computer programs that can beat humans at Tetris and some of the old school computer games. The chess masters, the AlphaGo, they're using reinforcement learning, which is you give an algorithm a goal, it will then try through trial and error to reach that goal. And if it fails, it will learn why and try something else. And obviously, if it succeeds, you get that positive reinforcement. Hence why the word reinforcement. And there, in the AlphaGo documentary, they talk about why this was so effective, which was because basically AlphaGo could play tens of thousands of games simultaneously, whilst a Go master can obviously only play one game at a time. So the rate of learning, the speed of learning, is so much higher in a machine when you're using a reinforcement learning technique than it is in a human.
Yeah, I think in the AlphaGo example, the grandmaster or equivalent of Go, I think, beat the computer in one of the games, but I think then after that, the machine outpaced him very significantly after that. Computer vision. So this is probably something that's less well known. So I think people probably seeing lots of CVs or profiles or job specs with those machine learning and AI. Again, as we've mentioned, maybe a little bit interchangeably or ambiguously used. But computer vision a little bit more novel. So talk us through what this means.
Yeah, so, fundamentally what computer vision is trying to do is give eyes to a computer. It wants a computer to be able to understand the content of images and videos. And again, this is where it's all very confusing, because computer vision uses machine learning, which is a branch of artificial intelligence. Now, you can achieve and build computer vision systems that doesn't use machine learning, but that was how it was done, back in the 80s and 90s. So nowadays, pretty much every computer vision system will use machine learning, might use deep learning, etc. So you can see how there's now a combination of techniques to achieve certain goals. And it is a really, really, really hard challenge. Actually, as humans, we don't really understand the science of how we see all that well. Like, as the best scientists in the world at a human level still don't quite understand it. So to replicate it in a machine is really, really difficult. And it's been, it's not a new concept. It's been around, like I said, for the last 50, 60 years. What has made significant advancements in computer vision is the combination of machine learning, deep learning, the volume of data, the computational power to process that data, etc. So that's what we mean when we talk about computer vision at a high level. If we jump on to the next one, the best example of computer vision is self-driving cars. So obviously, for a car to be able to drive itself, it needs to be able to see the surrounding environment, understand the surrounding environment, and take a decision. So it needs to understand the difference between a red light and a green light. It needs to understand the difference between a parked van and a moving van, etc. And we made some amazing advancements over the last 5 years when it comes to autonomous driving, autonomous cars. I believe, this is a personal opinion, and I'm not an AI researcher. I do not have a PhD in autonomous vehicles. So if there is somebody on the call that does, feel free to shoot me down in flames. But I believe the technology for self-driving cars is not in the too distant future, but actually it'll be the policy that will be the big challenge, and the politics behind it. Because in America, truck driving is, I think, they're the #1 occupation. So if you've suddenly got self-driving cars, you've got a lot of unemployment. You've also got the fact that people actually enjoy driving cars. And when we get to self-driving cars to a certain level, the reality is they're going to be safer than humans driving cars. So then you've got a moral question. Well, actually, you could save tens of thousands of lives a year with self-driving cars over human driving cars. So really fascinating topic, something that's going to be really widely discussed over the coming 10 years, I imagine. And yeah, I think we just had someone jump in there saying legislation, ethics, and insurance are further away than technology, which I absolutely agree with. But just to be really clear as well, so computer vision, key to self-driving cars, but I think this is one of the Google Waymo example. They're still using deep learning. They're still working on that neural net model. So it's not working in isolation. It's still working using those other techniques. So really exciting, really, really exciting to see what happens with computer vision over the coming years and decades.
Yeah, I think the complexity of this problem, I'm going to show my age here, but I remember being at a music festival and being bewildered by what I thought was a brilliantly framed picture of Damon Albarn at the Reading Festival. Didn't come out as brilliantly as I thought I'd framed it, because the camera didn't reproduce what I thought was a brilliant view from the middle of the mosh pit. But moving on. Natural language quotient, not to be confused with neural linguistic programming, which is the kind of Wolf of Wall Street, control people with your words kind of technique. Parking that to one side, talk us through this version of NLP, natural language processing.
Yeah, and I think what people will probably start to see is there's a common pattern here, which these different techniques are trying to replicate different parts of the human body. So whilst you've got, or human intelligence, so whilst you've got computer vision trying to replicate how we see and process images and videos, natural language processing is trying to do the same, but with language. So it wants to read, understand, and derive meaning from the human language. But as those of you that are interested in this will know, the human language is incredibly, incredibly complicated. It's not just about what we say, it's often about how we say it. Tonality plays a huge, huge part. So if you look at the three broad areas of language, generally, you've got syntax, which is what is grammatically correct. We saw a great example with deep learning impacting how we make something to be grammatically correct. You have semantics, which is what are they actually trying to say? Sarcasm being a great example of that. You may say one thing but mean something entirely different. And then the pragmatics, which I must admit I hadn't come across until I was doing a bit of research for this presentation today, which is what's the purpose or the goal of what we're saying. And that's what we're trying to do with natural language processing, is give machines the ability to do that to written and spoken English and human language. Again, with all of this, a kind of a broad approaches, and again, I'm not saying we're covering all of the approaches today, but just the most common ones. So the classic NLP technique was very rule-based, and you'll see this is a very common evolution, right? Early AI, very rule-based, will tell the machine what to do, and it kind of focused on pattern matching. To nowadays, what we're seeing with NLP will be a more cognitive-based approach, which we're trying to teach the machine, trying to let the machine teach itself the meaning behind the words, the actual understanding of the human language. And again, that's predominantly using deep learning to do that. Cool.
So a really simple example at the very sort of start of this process that might resonate with recruiters on the call. So if you think about searching CV databases, the classic example that job boards, I think, mastered a few years ago was distinguishing between CEOs and PAs to the CEOs. If you've been one of those people trying to headhunt the next senior leadership team for an organisation and found yourself speaking to a very junior secretary, it's that kind of problem that this NLP is trying to solve, but in a much more sophisticated manner as the technology develops, of course. Cool. So I've given you one ad hoc example from the recruitment world. Mark, give us another one.
Yeah, we could have made all of these examples more recruitment specific, to be fair. Apologies. But I'll leave that with Dale and his anecdotes. So a really cool example, which, again, I hadn't come across until I was looking for some examples for the talk today. There's lots of quite standard examples for NLP, but this one's really cool. So Amazon have built what they're calling Amazon Comprehend Medical. I'm not sure it's the best name in the world, to be honest, but we'll let Jeff Bezos do his thing. And what this is doing is you're providing their system all of your unstructured medical records about a person. So think if you're 50 years old, think how much medical records there are about you. And especially with the advancement of smart technologies and wearables, etc., we're getting more and more health data than we've ever had before. What this system by Amazon does is take all of that unstructured data, understand it, understand what's relevant, and then actually links it to scientific and medical ontologies and very nuanced things within the world of medicine. So how it's being used, and NLP is being used hugely across the health sector in the US, in the UK, etc., is to do better diagnosis and a much quicker diagnosis and a far more comprehensive diagnosis, because again, machines can process so much more data than humans can. So really, really cool example of how NLP is working in the medical sector to fundamentally save lives. And Amazon are at the forefront of that, as they are with most things in technology.
Cool. And now robotics. I think this is where people start to get excited and those sort of Terminator and Ex Machina kind of visions start to really come into play. Talk to us about robotics.
Yeah, really, really interesting topic. So So first and foremost, robotics is not a subfield of artificial intelligence. So you can absolutely have robots that do not use AI. So robotics itself is a branch of technology, not even a branch of computer science. It's a broad branch of technology in its own right. And a robot, by definition, are, as you can see, they're programmable machines that are used to carry out a series of tasks. And they could be autonomously or semi-autonomously. So if you think about robotics, probably a really good example is look at how cars are built these days. A lot of that's built by robots. Now, they're not necessarily artificially intelligent robots. They are programmed to do a very specific thing. Where it gets exciting, and I thought that Venn diagram at the bottom was perfect, was when you take robotics as a broad field, artificial intelligence as a broad field, and you bring them together. And that's where we get this concept of artificially intelligent robots. So if we move on to the next one there, we can walk through what artificial intelligent robots are. And so, I hate definitions that use the words, but in a simpler sense, take the concept of a robot, and instead of it being controlled by a series of programmed instructions, it's controlled by an AI, an artificial intelligent body, subject, etc. And why this is really exciting is because, using the car example, the robot that puts a car door on can only do that one task, and it's been programmed just to do that one task. When you combine robotics with the ability for machines to learn, they can perform far more complex tasks. And there, I know we've got some brilliant examples of this. I'll let you take the first one.
Well, I say the first one that springs to mind, I always go to Dilbert for my, if I don't understand something, it normally sheds some light or maybe clouds my understanding even further, but certainly entertains me along the way. So this is probably the more humorous side of things, of robots that are maybe somewhat conniving or with ill intent. But maybe some more real life examples are some of these, which I think people have seen on TV or YouTube or on news coverage of development of this technology. It's what people get very excited about this topic.
Absolutely. So probably, and again, don't quote me on this, but probably the leaders in the world at the moment are Boston Dynamics. So if you've not checked it out, I really, really highly recommend to go onto YouTube and search Boston Dynamics. It is amazing what they have built, to be quite frank. Terrifying, but amazing. Now, I think that to take it back to what we discussed at the start with the three types of AI, you've got narrow AI, general AI, and AI superintelligence or artificial superintelligence. Again, these machines aren't close to artificial general intelligence. So there still are a form of narrow AI where they are completing specific tasks, but it is incredible. Now, something is a little bit scary, which, Dale, I didn't realize this until I was just brushing up on this topic, was that actually Boston Dynamics is a military program in the US. So the purpose for what Boston Dynamics are doing is to be able to send robots in places where they don't want to send humans, whether that be rough terrains, or I'll let your imagination run wild with that, which is, quite scary. And I think this is where you get a lot of ethical questions around AI is, it does have the potential to be incredibly powerful, and that power should be likely shared amongst many people, not end up in the hands of the few. So you've got people working on something called OpenAI, which is an amazing initiative. Obviously, DeepMind's one of the best AI firms in the world, and they've got a really strong ethics board. And the concept of AI and ethics, though, might not be super interesting to our audience, is an interesting topic and something that is getting as much attention now as the technology behind AI. So I think we're done on the examples. Hopefully that gives a little bit more context to some of these buzzwords that are chucked around, how they all link together, etc. And hopefully gives people a better understanding of distinguishing between AI, machine learning, deep learning, computer vision, NLP, and robotics. I know we've received a couple of questions there on about how it relates to the world of work. So just to take a couple of these days, I'm not sure if you want to go through them one by one.
Yes, sure. So we've had one. So in your opinion, would you say that AI engineers or machine learning engineers are required to have development experience?
Yeah, great question. So we're going to cover this in a little bit more detail next week when we go through data engineering. But yes, predominantly Dale, if you flick to the next slide, we can run through these 4 different broad types of people that will be using AI daily. So you've got machine learning engineers or AI engineers, and they are building the fundamental machine that can learn, think, and carry out actions autonomously. Typically, those guys and girls, I use guys in a gender neutral way, will have really strong programming skills. Python predominantly used within the machine learning world. You then have research scientists and data scientists, which are slightly different. Data science, as we've already covered, is about using AI, not always, but using data to gather insights from unstructured data and present that back to the business. Research scientists are more broad across multiple different AI disciplines and might be building actually like the theory behind what then the machine learning engineers go and implement. So a research scientist might be very strong academically in their field, still working in a commercial environment, but working really academically, and then the machine learning engineers will go and build it. And the data engineers are building all of the different various systems that you can talk together, put your data in one place so that you can analyze it. So that's how the AI is used, and hopefully that answers the question that yes, broadly speaking, they require development experience.
We've also been asked, so obviously last week you spoke about the books from MIT, the MIT Press Essential Knowledge series. Do you have any that you would recommend on AI? I know that personally I would recommend AI Ethics. It's really good. It's kind of a really good kind of look into the ethics surrounding AI, and it definitely talks about Google and Siri and stuff, and it's quite a nice kind of broader overview. So that would be my personal recommendation. I don't know if you guys have any that you would add as well.
Yeah, there's, again, very broad topics. You can go in quite a few different ways. So Nick Bostrom wrote Superintelligence, which I think is widely considered to be one of the best books on AI. And it's not too academic, so it's quite an enjoyable read. That MIT series you mentioned, they've got one on machine learning that I've read, which is really, really, really good. I think it's just a brilliant series. I would really recommend checking out all of their books. And amazing way to learn something in 150 pages. And then I can't remember who wrote it. I think his name was Max something. We'll follow up with it. He wrote Life 3.0. I'm not sure if Dale or Days if you've read it, but it's going more into the artificial super intelligence world, and it's brilliant. It's a non-fiction book, so it's factually based, but reads like a sci-fi book. And then there's another one.
Tegmark.
What was his name? Sorry, Dale?
I think it's Max Tegmark, according to Google.
I'm very happy I got the Max right. And then there's another one, which I can't remember the exact title, but I think it's To Be a Machine, which talks a lot about the weird cult of people freezing their bodies when they die, in the hope that we will basically be able to port our brain, which is what makes us human effectively, and put it into like an artificially intelligent robotic body. Because actually, if you look at the hardware of a human, like our limbs, etc., we're not actually that good. We can't fly, can't jump very high, can't actually run that quickly for a sustained period of time. So there's this whole movement, I'd say it's quite a niche movement, of like the idea of taking all of our intelligence but putting it into a new hardware that allows us to do a much more. So that, I think that one's called To Be a Machine. So yeah, so some brilliant books. We'll pop them all in a Slack channel afterwards as well, but tons of great books on this content.
And finally, we've been asked, how are we personally using AI techniques at HackerJob?
Oh, great question to end on. So if you think about everything we've discussed today, what AI can do really well is take vast amounts of data to make better decisions than humans. So where we use machine learning in HackerJob is our matching engine. So we can make much better recommendations to our clients on the candidates they should be seeing using machine learning rather than using humans, because the machines can just process more data than a human can. And it can, again, lead to a much more unbiased system, as long as you train it on an unbiased data set. Again, AI ethics, very interesting. Where we think the humans are vital in the candidate experience side, which is why humans are a core part of our strategy as well. But that's our specific use case at HackerJob.
Cool, great moment to round off the session. Thank you, Mark. Thank you, Daisy. And thanks everyone that tuned in. And we'll see you next Tuesday for our session about data engineering, a deep dive there. So quite a lot of overlapping subject matter here. So if you enjoyed today, we think next week will be a great session for you as well. Have a great rest of the week, and we'll see you all soon. See you in the Slack channel.
Amazing. Cheers, guys.
Cheers. Bye.